Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email and to schedule your class. So with this, let's get started with this paper. Thank you. Hello. So today we'll be solving the November 2024 Paper-1 Chemistry HL paper. Let's start with the first one. Now in the first one, we have to find the moles of phosphate ions and 103.39 grams of calcium phosphate. So we'll first find the moles of calcium phosphate. Yeah. So moles of Ca3PO4 whole twice, this will be 103. So 103.39 can be approximated to 103.4 and this can be written as 310.2, right? So 103 times 3 is 309 and 0.4 times 3 is 1.2. So basically this ratio would be 1 over 3. This is the moles of Ca3PO4 whole twice. So moles of phosphate ion PO4 3 minus. So in 1 mole of CH3PO4 whole twice, you have 2 moles of PO4 3 minus ion. So it will be 2 times 1 by 3. So it's 2 by 3. 2 by 3 is approximately 0.67. Answer is option C. Now moving on to the next one, we have to balance this and we have to find the sum of the coefficient. Now starting we have O2. So O2 is the free element, so we'll balance O2 at the end. So starting we have to put 2 in front of Fe to balance the iron. Then to balance sulfur we have to put a 2. So on the right side we have 4 plus 3, 7 oxygen. So I have to put 7 by 2 in front of O2. This will actually balance out the entire reaction. Now to make everything an integer, I'll multiply both sides with 2. That will make 4 FeS plus 7 O2, giving you twice Fe2O3 plus 4 SO2. Now if I add up the coefficients, I'll get 4 plus 7 plus 2 plus 4. 4 plus 4 is 8, 8 2s are 10, 10 7s are 17, which is option D. Moving on to question 3, we have to find the yield of sodium chloride when 4.6 grams of sodium reacts with 1.14 dm cube of chlorine gas at STP. So let's start by finding the moles of sodium and chlorine. So moles of sodium would be 4.6 divided by molar mass of sodium is 23, 0.2. Moles of Cl2 would be 1.14 divided by 22.7. Okay, so yeah, so if I do 2.27 divided by 2, I'll get approximately 1.14. So 2.27, 22.7. This will give me 0.1 over 2, 0.05. I'll find N by SC for sodium. Sodium moles is 0.2, stoichiometric coefficient is 2, and mole per stoichiometric coefficient for chlorine would be 0.05 by 1. So as Cl2 has a lower value, so Cl2 is the limiting reactant. And now I have to find the moles of NaCl. So if I take the molar ratio of NaCl and Cl2, it's 2:1. So moles of NaCl, it will be twice the moles of Cl2. Yeah, moles, that's 0.1. And the mass of NaCl will be 0.1. Sodium is 23, chlorine is 35.5. Will be 0.1 times 58.5. Gives you 5.85 grams, which is option C. Now moving on to the next question. We have to find the pressure in a 3 dm cube cylinder containing 64 grams of oxygen at 25 degrees Celsius. First find the moles of oxygen. 64 divided by 2 times 16, which gives me 2. R is 8.314. Temperature is 273 plus 25, which is 298. Okay, and volume is 3 dm cubed. Fine. So pressure, if I take volume in dm cube, my pressure will be in kPa. So it will be nRT by V. So P is 2 times 8.314 times 298 divided by 3. The unit will be kPa, right? So remember, if you use volume as dm cube, your pressure will be in kPa. But I have to report the answer in PA. So kPa to PA is times 1000. PA. 1 by 1000 can be written as 10 to the power minus 3. So I can also write it like this. Divided by 3 times 10 to the power minus 3 PA. Now if I look at the options, it matches with option B. Now moving to the next question. We have to find the average atomic mass from the mass spectrum. So AR would be summation of abundance times mass by 100. So abundance is 80.1 times 10. The abundance is 80.1, 10 is the mass for the first one. Second one is 19.9 times 11 by 100, right? From here, AR would be, it will be 801. 19.9 times 100, 19.1 can be written as 20 minus 0.1 times 11, 100. So AR would be 801 plus 20 times 11 is 220, and this will be 1.1 by 100. From here, it will be 1021 minus 1.1 by 100, 1019.9 by 100, and this will give me 10.199, which is approximately equal to 10.2, which is basically our option B. So this is how you can solve it without a calculator. And yeah. Now the next question. So we have to find the what's correct about the wavelength and energy of the radiation of UV and visible region. So we know that UV rays are harmful for us because UV causes cancer. Yes. So if it causes cancer, of course it has higher energy compared to visible light. That will basically trigger the mutations in the cell. So has higher energy. Done. So I know that UV will have higher energy and visible will have lower energy. So I can eliminate option B, option C. Now E equals hc by lambda, right? So E is inversely proportional to lambda. So higher energy means lower wavelength, right? Higher energy means lower wavelength. So higher energy, lower wavelength for ultraviolet is in option A. And that's the correct answer for question 6. Now moving on to the next one. So here is a graph of 10 ionization energies of an element, right? You identify what is the element. So first I'll check how many valence electrons are there in this element. So you have 1, 2, 3, 4, 5, 6. You have a total of 6 valence electrons, right? And we know that 6 plus 4, it will have either 10 or more electrons. Total electrons would be greater than equal to 10. Now chlorine has 7 valence electrons, so chlorine cannot be the answer. Neon has 8 valence electrons, a noble gas, cannot be. Oxygen has 6 valence electrons, sulfur has 6 valence electrons, right? But total electrons in oxygen would be 8. This is less than 10, right? So C cannot be the answer. And final answer for this will be D, sulfur. Because sulfur has 6 valence electrons and it has more than 10 electrons in total. Now the next part. So we have COH2 whole 6 3 plus and COCN6 3 minus. COH2 whole 6 3 plus is blue while COCN6 3 minus is pale yellow. So which statement correctly explains this difference in color? We can start with option elimination, of course. So Cn minus is weaker. This thing is wrong, right? Because Cn minus is stronger and H2 is weaker. So I can eliminate the first one. Oxidation state of cobalt is different in each complex. Not the case exactly. If I find the oxidation state, 6 times hydrogen has 0, plus 3. So for the first one, oxidation state is plus 3, X. So the next one, if this is CO, is X. Cn minus, so minus 1. X will be minus 6 plus 3, so X is plus 3. So we have same oxidation state in both, so B is wrong. Different colors are due to different charges on the complex. This is not the case. The colors always come because of the ligand, right? And not because of the charges. So from this, I can say D will be the right answer by elimination, but D can also be explained. Right, so basically, for the first one, it's showing a blue color. Blue color means it will absorb orange. Okay, next one, it's yellow, right? Or pale yellow, whatever. Pale yellow means it's actually absorbing violet. Okay, and I know violet has a higher energy. In Vibgyor, violet has the highest energy, red has the lowest energy. Okay, so this is actually the thing here because ligand causes larger 3D orbital splitting and absorbs light of higher frequency. So violet has higher energy and also it'll have higher frequency. So option D is correct for question 8. Moving to the next one. Which of these period 3 oxides will form a solution with pH less than 7? So which one will form an acidic solution, right? MgO will form MgOH whole twice. This is basic. Cannot be B. Al is amphiprotic, so I'm not eliminating just now. Na2O will form NaOH, so this can also be eliminated. P4O6 will form an acid, like H3PO4 or something like this, right? Al2O3 can also be eliminated as this amphoteric. Can act both like an acid or a base. So only option D gives you an acid, right? So pH will be less than 7. Now moving on to the next one. Which electronic configuration that of a transition element in ground state? Transition element will have electrons in its d subshell, right? It will have a half-filled d subshell basically. First one is wrong because there is no d subshell. C is also wrong because d subshell is completely filled. Now B and D, it says in ground state. In B, you see that the 4s2, the 4s2 configuration is missing. That means what? Whatever the electronic configuration is, right? Electrons have been lost by this atom. So this is not exactly in the ground state. So can also be eliminated. But the last one is fine. Last one is basically the electronic configuration of chromium in ground state. There is an exceptional electronic configuration. But yeah, chromium exactly has 4s1 3d5. So option D is the right answer for question 10. Question 11. Which type of intermolecular force exists between CH4, CH3OH and CH3Cl? CH4 is non-polar, right? So it will only have London dispersion forces. Okay, only one force, which is London dispersion. From here I can eliminate B and D, right? CH3OH. In CH3OH you see hydrogen is directly attached to oxygen, right? So it will have hydrogen bonding. Done. Second, OH is like, the OH group is a polar group, so this is a polar molecule. As it's polar, it will have dipole-dipole interaction. And London dispersion forces are present in every molecule, so it will also have London dispersion. Yeah. From this, I can eliminate option C because here hydrogen bonding is missing. So I know option A is the answer, but for CH3Cl, it does not have hydrogen bonding, but it's a polar molecule. So it will have dipole-dipole. And it will have London dispersion forces. With this, I can say is the correct answer. Moving to the next one. What is the molecular geometry and hybridization of the numbered atoms in the shown molecule? So I'll actually calculate how many electron pairs are around the central atom. Right. So electronic pair, if I want to calculate the number of electron pairs, I take double bonds as a single electron pair like this. Okay. So for this here, it has 1, 2, 3 because there's a hydrogen attached. 3 electron pairs. Okay, or 3 groups basically, 3 electron groups. 3 groups means the hybridization will be sp2. So C2 will be sp2 hybridized, and here there is no lone pair. So it will be sp2 trigonal planar. This one, 3 groups. Okay. So it will be sp2, and as there are no lone pairs, it will be trigonal planar. From here, I can eliminate option B, option D. For the third one, there are only 2 groups around carbon. One is a single bond, other one is a triple bond. So hybridization is sp. Sp and 2 groups, there are no lone pairs, so it will be linear. Okay. With this, I can also eliminate option C. Because it will be sp linear, not bent. And for this one, for 3, there are basically 3 electron groups around nitrogen. Out of that, you have 1 lone pair and 2 bond pairs. So 3 groups will make it sp2 first. But if you have 2 bond pairs and 1 lone pair, right, this will give it a bent structure or a bent shape. So option A is the right answer for question 12. Now the next one, you have to find the number of sigma and pi bonds present in the molecule. First, let's draw the molecule. See, each carbon has 2 CN. CN is 3 triple bond N. C triple bond N, C triple bond N, C triple bond N. So you see each carbon has 3. So if I place a double bond, it will be balanced. Yeah. Number of sigma bonds. Each bond will have one sigma bond. So one sigma bond here, one here, one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You have total of 9 sigma bonds. Okay. And for pi bonds, there will be 2 pi bonds in the triple bonds, right? 2, 2, 2, 2, and 1 pi bond in the double bond. 0 pi bonds in the sigma bonds. 2 to the 4 to the 6 to the 8 and 1 9. So I have 9 pi bonds. 9 sigma 9 pi. Answer is option B. Yeah. Now the next one. Which statement is correct for alloys? So for alloys, the first option is like the mixture of metallic cations of different sizes increases the strength of non-directional metallic bonding, making the alloy harder than the parent atom. So this is actually correct. So atoms of different sizes will disrupt the regular lattice structure of metals, and yeah, that will make the layers harder to slide on over each other. So first one is correct. Next one, different sizes of atoms in alloys prevent layers of metallic cations sliding over each other easily. I just said that. This is also true. Last one, adding carbon to iron produces an alloy that is stronger than pure iron. Exactly so. So here we are talking about the production of steel. Steel is much stronger than iron. So the third one is also right. So for question 14, answer would be option D. Now moving to the next one, question 15. What are the signs of delta H, delta S for the reaction that is spontaneous at high temperatures and non-spontaneous at high temperature, spontaneous at low temperature? So here, just a thing. So liquid plus solid becomes a solid. So guys, for randomness is decreasing because your liquid is getting converted to a solid. So I already know that delta S would be negative. With this, I can eliminate option A, option C. Right. Now, it says spontaneous, non-spontaneous at high temperature, spontaneous at low temperature. So delta G would be delta H minus T delta S. Yeah. So basically, just to think that T delta S term is actually positive because delta S is negative, right? So negative T delta S, overall when you combine delta S with it, you'll have a positive number here, right? And for a reaction to be non-spontaneous, to be spontaneous, delta G has to be negative, right? So for this, if first thing is H has to be negative, H has to have like a very high negative number so that delta G is spontaneous. At low temperatures, what happens is this negative T delta S term will have a smaller value, right? At low temperature, as T has a smaller value. As a result, delta G will become positive. Delta G will become negative. Sorry for that. Yeah. But at high temperature, at a high temperature, this T delta S term will have a high positive value. As a result, this can be greater than delta H and will make the reaction non-spontaneous. So delta H has to be negative and delta S is also negative. Answer is option B. Yeah. Now moving to the next question. We have H2 plus, so we have there's a Hess law problem. Let's try this. So we'll use equation manipulation. So first, C2H2 is on the reactant side. So I'll first reverse the first reaction. C2H4 giving you 2C plus 2H2. Delta H will be negative Z. Okay. Next, CF4 is on the right side, but the coefficient of CF4 is 2. So I'll multiply 2 with the second equation. 2C plus 4F2 giving you twice CF4. Delta H would be negative 2Y. And the last one, you have 4HF actually in our reaction. So I'll multiply the first equation with 2. Twice H2 plus twice F2 gives you 4HF. Delta H would be negative 2X. When I add everything up, let's see what I get. So 2C cancels out, 2H2 cancels out. So finally I should have C2H4, 4 plus 2 I'll have 6F2. This will give me twice CF4 and it'll also give me 4HF, which exactly matches to the equation. So delta H would be, so writing it here, delta H would be negative 2X, negative 2Y, negative Z, which matches with option D. And D is the right answer. Now, moving to the next question. So which of the two diagrams represent the Maxwell-Boltzmann distribution of kinetic energy where T1 is greater than T2? Okay. So what happens is for the higher temperature, the graph will be flatter, right? maxima will shift to the right and will have a lower fraction of molecules. This is for the curve at higher temperature. Right? So first thing is T1 will be flatter and the maxima of T1 will be right and a little bit below. Eliminate option A, I can eliminate option C because maximas are at the same height. In option D, T2 is flatter and the maxima of T2 has shifted to the right a little bit. I know that T1 is greater than T2, so this cannot be true. So of course answer is option B, because here you see the maxima, it has shifted to the right and it has gone down. It has a lower fraction of molecule and also the curve has become flatter. So this will be option B. Moving to the next one, what is the enthalpy change in kilojoules per mole when 107 grams of ammonium chloride added to water to form 50 centimeter cube solution producing a maximum decrease of 28 degrees Celsius? Right. First find the moles of NH4Cl. So 107 mass divided by molar mass is 53.5. This will be 2. Okay. Now how much heat will be, how much heat is released? Basically it will be negative 50 times 4.18 times delta T is 28. Now why mass is 50? Because density of water is 1 gram per centimeter cube. So 1 centimeter cube of water will weigh 1 gram. This is the mass. C is 4.18 it's given and delta T is a decrease of 28. So delta T is basically negative 28. This is Q, right? Delta H will be negative Q over N. Minus of minus 50 times 4.18 times 28, N is 2, right? So delta H will be 50 times 4.18 times 28 by 2. The unit will be joule per mole. But I need the answer in kilojoules per mole as stated in the question. So joules to kilojoules, I have to divide it with 1000. 2 times 1000. Unit will be kilojoules per mole. And from this, I can say the answer would be option D. Yeah. Now for question 19, we have decomposition of H2O2, right? So which curve represents a catalyzed reaction performed at same temperature and same concentration? Same temperature, same concentration means I'll get the same amount of final products. And eliminate option A, I can eliminate option D. As I use the catalyst, the reaction will be faster. So if you see here, there's a final, like the final concentration line is this. So in the path B, we are reaching the final concentration much faster as compared to C. So B is our catalyzed reaction and B will be the path. So answer would be option B. Now moving to the next question. Yeah, if we have the graph between ln k and 1 by t, we have to find what the slope of this line represents. So ln k is on the y-axis, 1 by t is on the x-axis. So I can write the equation as y equals minus Ea by r x plus ln a. Compare it with y equals mx plus c. So whatever multiplied with x, that's my slope. So slope would be minus Ea by r. This is the slope and our answer would be option A. Moving to question 21, we have to find the rate expression. So the slow step is given, so rate will just be k times NO2 whole squared. This is the answer, which is option A. Yes. So, okay. Yeah, moving to the next one. Carbon dioxide dissolves in water as shown in the equation below. What will happen to the temperature of the aqueous solution is increased. So remember one thing here, that in the forward direction, heat is released. Okay, as it's an exothermic reaction. And in the reverse reaction, heat is absorbed. So if you're increasing the temperature of the solution, the reaction will try to reverse it. The reaction will try to absorb heat and decrease the temperature of the solution. As the reaction absorbs heat, that means equilibrium shifts to the left. if the equilibrium shifts to the left, I can eliminate option A, I can eliminate option B. Yeah. Now, as the equilibrium shifts to the left, the H3O plus concentration decreases. Yeah. Because it's on the right, so H3O plus gets consumed. As this concentration decreases, basically I can say pH increases. So answer would be option C. Moving on to the next part. So we have delta G equals minus RT ln K. We have to find out which such statements are correct for the position of equilibrium. So it will always shift to the right when temperature increases. This statement is wrong because the the equilibrium will shift to the left or right, depends whether the reaction is endothermic or exothermic, right? And this relation delta G equals minus RT ln K is valid for both of the types of reactions. So the first one we cannot say whether it's true, so this I can cancel out. Next one, when delta G is less than 0, delta G less than 0 means the reaction is spontaneous. Then K is greater than 0. Of course, if the reaction is spontaneous, so spontaneously products are produced. K greater than 1 means products are favored over reactants. So second one is correct. Third one, when delta G is equal to 0, K is equal to 1. Yeah. Delta G will only be equal to 0 when K is equal to 1. Right? At that point, when K is equal to 1, the reactant and products are approximately equal. That's true. Right? Also so true. So 2 and 3 are right. Answer would be option C. Moving to the next part. pH of an aqueous solution Z is 5 and pH of an aqueous solution X is 10. Ratio of their H3O plus concentration. Okay, so for Z, H3O plus concentration is 10 to the power minus 5, 10 to the power minus pH. Yeah. And for X, H3O plus concentration is 10 to the power of minus 10. So basically pH is minus log base 10 H3O plus. So from here, H3O plus would be, if I just take a anti-log, it will be 10 to the power of minus pH. Yes. If I do Z over X, it will be what? 10 to the power minus 5 by 10 to the power minus 10, which will be 10 to the power 5. So I can say H3O plus is 10 to the power 5 times lower in X as compared to Z. Answer is option D. Moving to the next part, we have to use the data to show which conjugate base is the strongest. So I have to find the weakest acid here. The conjugate base of the weakest acid will be the strongest base. Weakest acid means smallest Ka means the weakest acid. Okay. Yeah. So here HClO, it has the highest, smallest Ka. 1 second, yeah. Smallest Ka, right? So conjugate base of HClO will be the strongest acid. So HClO conjugate base will be ClO minus, yeah, which is option A. This will be the strongest conjugate base. Next one, consider the phosphate buffer system Na2HPO4 and NaH2PO4. What is correct when small amount of strong base is added to the buffer? Okay, small amount of base will be added. So like here, this one will be the acidic component and this one will be the basic component, right? So if strong base is added, this part will react. So H2PO4 minus will react with the OH minus. This will give me HPO4 2 minus, okay, and H2O. HPO4 2 minus is present in Na2HPO4. So basically at the end of this reaction, HPO4 2 minus is formed, so I can say option C is correct. B is wrong because H2PO4 concentration decreases. OH minus reacts with H2PO4, that is correct, but forms HPO4 2 minus, not PO4 3 minus, also wrong. And OH minus does not react with Na plus, so A is also incorrect. Moving to the next part, we have this simple acid, okay, 25 centimeter sample of weak base is titrated with HCl. We have to find the pKb of the base. So yeah, so this is 25 centimeter cube, right? So you have to find the half equivalence point, which is 12.5. 12.5 will approximately be in the midpoint of these two. When I go here, the pH is 9. pH 9 means the POH would be 14 minus 9, which is 5. So pKb of the base would be 5. So answer would be option B. in what reaction H2 acts as an oxidizing agent? So H2 acting as an oxidizing agent means H2 gets reduced. H2 can only get reduced to H minus ion. So we have to see in which of the reaction H minus ion is getting produced. NH3 oxidation number of hydrogen is H plus, wrong. NaH. In NaH you have H minus ion. Basically Na plus and H minus is the hydride ion. So B is the right answer. In HCl you have H plus again. H3C, CCH3 again H plus. So answer would be option B. So just write the reaction. This is the reduction of H2. Now the next one, 29. So a voltaic cell is constructed from half cells using metals X and Z as electrodes. What will occur when the cell produces electricity? So basically for this, I have to reverse the second reaction. And Z gives you Z2 plus 2 electrons. Okay, so after this, basically if I add the cell values, E naught value will be 0.25 minus of minus 0.6, 0.85 volts. So this, if we have these reactions, then our cell will produce electricity. Okay, now let's try to understand. Positive ions flow from salt base to Z half cell. Z is producing Z2 plus ions, right? So it requires negative ions to neutralize the charge, not the positive ions. So first one is wrong. Next one. Electron flow from X to Z. Wrong. Z is producing the electrons. X is consuming the electrons. So electrons will flow from Z to X. Okay. Second one is also wrong. The concentration of X2 plus increases. This is wrong because X2 plus is getting consumed. X2 plus 2 electrons gives you X. Concentration of X2 plus actually decreases. Again, C is wrong. But for the last one, mass of electron Z decreases. This is correct because mass of the electrode, electrode Z is basically participating in the second reaction. Z is becoming Z2 plus 2 electrons, right? So as a result, mass of electrode Z decreases. This is the right answer. And the answer is option D. Yeah. Now moving to question 30, which statement is correct for a reaction in the voltaic cell for which both delta H and delta S are positive? Okay. So delta H and delta S are positive, right? That means delta G would be delta H minus T delta S. It will only be spontaneous at higher temperatures when T delta S term is bigger than delta H. At high temperatures. Fine. So when this is spontaneous at higher temperature, what happens is, I can eliminate option D. It's not spontaneous. I mean, delta G is negative for higher temperature, positive for lower temperature. Okay, and the delta G value keeps changing with temperature. So as delta G keeps changing, I can also eliminate option C. E naught cell will change as when the temperature increases. But when the temperature increases, what I'm saying is that delta G becomes more negative, reaction becomes more spontaneous. If the reaction becomes more spontaneous, what happens is the E naught cell value increases, which makes option A the right answer. Okay. More negative, E naught cell will become more positive. So basically E naught cell increases. Yeah. Now the next one. Which statement is correct for the value of E naught for standard hydrogen electrode SHE? So first thing, SHE was not experimentally determined. It was a value which was agreed upon by the scientists. So E is incorrect. B, it depends upon the temperature. This is also wrong. E naught cell is always maintained at 0. So whatever temperature it is, the SHE will always have the E naught value of 0. B is wrong. C, it was an arbitrary set. I think this one is the right answer. Because it was chosen by convention as a reference point for comparison and to set values for the other reactions, the E naught value. So C, I think, is the right answer, and D, depends upon the E naught value of second electrode. Wrong. You can put whatever you want for the second electrode. The electric potential for hydrogen electrode will always be 0. So yeah, C is the right answer. Next one. What are the functional groups present in aspartame? Okay, so here I can see the end we have a carboxyl group. This is a carboxyl group. This is an ester group. CH3, COOR prime, that's an ester group. So carboxyl and ester are present. So I can eliminate option A, I can eliminate option C. Okay, now there are two more groups. NH2, this is a primary amine group, primary amino group, right? And CONH, this is basically an amide group. Okay, I don't see amide in the options, but I see primary. So this is not a secondary, secondary amino groups. Is to the totally is called an amide group. So option D is the right answer, and I can also eliminate option B. Yeah. Now the next one, I have to find the IUPAC name of this compound. I'll start from here. 1, 2, 3, 4, 5. Right. 5 means it's pent. Group is also pentanal. Pentanal, all single bonds, so in and all. Now the and the groups, which is 2 and 3, 2,3 dimethyl, 2,3 dimethyl pentanal will be the answer, which is option A, because at 2 and 3 position we have 2 methyl groups. Okay. Moving on to the next one. Which of the following compounds can react with acidified potassium dichromate to give an acid? Right. So for the first one, CH3. It is a secondary alcohol, right? So if I put K2Cr2O7, right, it will become a ketone, but not a carboxylic acid. So A cannot be the answer. B, CH3, COCH8. This is a ketone. Ketones cannot be further oxidized by K2Cr2O7. Okay, B is eliminated. Next, yeah. So there's a big compound. So CH3, CH2, CH. This is CH2OH. Just drawing the entire structure here. CH2, CH3. So here, if you check, this OH is actually a primary OH, because the carbon atom with which the OH is connected with only one other carbon atom, right? This will actually give me a carboxylic acid, which will look like this: CH3, CH2, CH, COOH, CH2, CH3, right? So option C is the right answer. And option D cannot be a right answer, because if you check here, it's a tertiary alcohol, and tertiary alcohols cannot be oxidized. No reaction. So answer is option C. Now for the next one here, you have to find out how many optical isomers exist for ascorbic acid. So ascorbic acid is also vitamin C, as you know. So looking for chiral carbons, this carbon is not chiral. This is a chiral carbon. This carbon has 4 different groups. This is a chiral carbon. This carbon is not chiral because it's sp2. This is also not chiral as its sp2 has a double bond. This is also not chiral as it has a double bond, right? So we have 2 chiral carbons. Number of optical isomers, it will be 2 to the power of n, or 2 squared, which is 4. Answer would be option B. Okay. Now the next one, we have a tertiary halogenoalkane reacting with NaOH. If it's tertiary, then SN1 will be favored over SN2, as carbocations will be easily formed rather than an attack by nucleophile, right? So I can eliminate option A, option D with this. Now for SN1, the reaction is first order. For SN1, the rate would be like this. It's K times the substrate concentration. Substrate means the reactant concentration, right? So here for option C, you see that it's a second order rate equation. This cannot be true. So C can be eliminated and B is the right answer. Here you see rate is K times only the substrate concentration. And for 36, B will be our answer. Moving on to 37, which of the following compounds will give an optically active compound on reacting with LiAlH4? Okay, LiAlH4 means it will be a reduction process. Propanol. This is propanol. Yeah. If I do LiAlH4, it will give me CH3, this will be CH2, sorry. Yeah, CH2, COH, H. Fine. So this is not optically active. First one will be cancelled. Next is butanol. CH3H. Butanol, if you react it with LiAlH4, it will give you CH3, CH2, CH2, COH, hydrogen, hydrogen. So you see, you have 2 hydrogens with this carbon and all the other carbons have like 2 or more hydrogens. So this is also not optically active. You don't have a single carbon with 4 different groups. So B is also wrong. Butanone. Butanone is a ketone. Look like this. If you put LiAlH4, you will get CH3, COH, H, CH2, CH3. Now if you look at this carbon, right, this is one group, this is a different group, this is a different group, this is a different group. So 4 different groups are attached to this carbon. That means this is a chiral carbon. So butanone is actually optically active. Answer is option C. Okay, propanone cannot be the answer because propanone is this. If I put LiAlH4, I'll get CH3, COH, CH3H. So you see, 2 same groups are attached to this carbon. So this carbon is not optically active. So this is also incorrect. Answer would be option C. Moving to question 38. Which statements are correct about the molecular ion M+ in a mass spectrum? Okay, so M+ is not always the peak with highest intensity in the mass spectrum. This is true because M+ may or may not have the highest intensity. Okay. Next one, M+ is always the most stable for a fragment formed during electron bombardment. This is not correct because M+ may not be the most stable thing, as you know, as it can easily fragment into smaller and more stable ions, right? So option 2 is incorrect here, of course. And the last one, M/Z ratio of M+ ion peak gives the relative molecular mass of the molecule. This is fine because from the M+ ion peak actually gives us the molar mass of the compound, right? So 1 and 3 are only correct, which is option B. Now moving to the last part, we have which compound gives you this HNMR spectrum. So guess what? There are 3 peaks. That means 3 hydrogen environments. Yeah, as you have 3 different peaks here. Now we'll count how many hydrogen environments are present in each and every molecule, right? For this one, you have 1, 2, 3. For option A, there are 3 hydrogen environments. Okay, so A can possibly be an answer. For option B, you have 1, 2, 3, 4, 5. 5 hydrogen environments, so B cannot be the answer. For option C, you have 1, 2. As it's symmetrical about O, you just have 2, like only 2 hydrogen environments. So C cannot be the answer again. For option D, here you can you only again have just 2 hydrogen environments because it's symmetric about this point, all the methyl groups, right? So again 2 here. So from here I can say option A is the right answer to this question, as A has 3 hydrogen environments. Now the last question of this paper, a student performs an experiment to determine the content of ethanoic acid in vinegar samples using a non-standardized sodium hydroxide solution. What type of error will occur and how will this affect the quality of data obtained? So, as the exact concentration is not known, right, it will introduce a systematic error and all measurements will constantly deviate from this value, right? So there will be a systematic error but not a random error because concentration of NaOH is not known. Eliminate option C, option D. But if someone is performing the experiment properly, the reaction or this experiment will have high precision. Okay, but the accuracy will be low because there is already an error in the experiment. So from this I can say A is the right answer. So systematic error because the concentration is not known, right? And it will have higher precision if the experiment is performed properly. And yeah, the accuracy will be low because of this existing error. So with this, we finish this paper. Thank you so much and see you again in paper 2. Thank you.